Hi guys, good afternoon everyone. So hope everyone is doing fine. Participant sides, can you guys quickly confirm if you are able to see my screen and you able to hear me properly so we can start now. So I can see still people are coming up in the meeting. So meanwhile everyone joins in guys, let me write the agenda for today. Okay, Dharam sir, good afternoon. Hope you are, I am audible and you are able to see my screen as well. So guys, we're going to start first today with decision tree, decision tree algorithm. And meanwhile, while we understand the decision tree, guys, we'll try to also understand the random forest. So it is one of the ensembling technique, not ensemble technique, random forest. So the collection of the trees will be forest. So that's how it's gonna be. So it is very relevant. So in first half, like for 1 hour actually, we'll try to understand these two algorithms today. And then guys, once we are complete, once we make a code walkthrough, actual topic for the today will be the artificial neural network. Artificial neural network. Artificial neural network. All right. So this we'll try to understand what is artificial neural network, how they are trying to copy the human brain, and how the actually the artificial intelligence came into the picture, how it is working, what is this entire architecture is there, what is the mathematics behind it, and if the time permits today as well, we'll try to make a code walkthrough. Otherwise, tomorrow we'll make a code walkthrough. I am not sure whether we'll be able to cover entire artificial neural network today. So we'll try to continue our discussion tomorrow as well. We'll start with the artificial neural network, sorry. And then tomorrow we'll try to dedicate entire time for the NLP. NLP is one of the favorite topics nowadays. So this is how it's gonna be. So guys, before we start, any suggestions, anything, you can start interacting with me, guys. So hope everyone is comfortable with the agenda. So everyone know what is there in our plate today. So it's already the time. So let's get started then for the agenda. So let me stop sharing my screen and let me share my OneNote, guys, with you. And once I share my OneNote, you guys can just give me confirmation. Yeah. So let me share my OneNote. Right. Okay. So everyone can see the OneNote. Dharam sir and other guys, quickly give me confirmation. Okay, thank you, ma'am. Anjali ma'am, thanks. Srinivas sir, thank you. Thanks, guys, for confirmation, and let's get started then. Let's get started. Let's start with the decision tree then. What do you mean by decision tree? I'm sure that most of us are already heard about the decision tree because it is one of the favorite topic, mathematical topic in our algebra, in our school days and also in the college days. So before we deep dive into the topic, can anyone would like to brief me, like what is decision tree and what is it all about? One-liner definition will be sufficient for us. So guys, quickly share your thoughts. Please let me know what you mean by decision tree or any idea what decision tree does. Any kind of introduction, any kind of a summary you would like to give everyone. Come on, guys, try at least. Let me know what you guys know about the decision tree. And we'll try to build our knowledge today on the decision tree. Decision tree is one of the versatile algorithm, guys. So superb algorithm. So we'll try to understand the mathematics behind it, how it does, what exact criteria it uses. So guys, question is clear for everyone. I hope my question is very, very clear, everyone. So what is decision tree? If you have any idea, any fantastic clue, what is this decision tree is all about, and please let me know. Okay, but Savraj sir is saying parent node, child node, right, left, non, awesome, non-parametric, awesome, awesome, sir. Non-parametric, awesome, Basaraj sir, thank you. Srinivas sir, thank you. Awesome explanation. So anything else, guys? Any other thoughts? Anything else? Parent node, child node. Yeah, that's what we're going to divide the things, right and left. Awesome, cool. Yes, it is non-parametric algorithm. So it is not a linear algorithm. It's a non-parametric one. It is cannot be fitted into the equation like y equal to mx plus c. That's why it's non-parametric. Awesome. Anything else, guys? Anything else? What it does? Any simple property of the decision tree? What is the benefit? Like wow, it is called as versatile. Any introduction line, if you guys feel before we start? Anything else you guys would like to add? What is decision tree all about? All right, guys. So I think yeah, we have got enough of replies. Yeah, we can start then. All right, guys. Okay, let me see what utilizing both classification migration. Yes. Awesome, awesome. Correct, guys. So let's try to understand, guys. Let's try to understand what is the decision tree. So, guys, a decision tree, one of the supervised algorithm, one of the supervised algorithm. Now, when I say it is one of the supervised algorithm, we are already telling it that what kind of a data is there, and we are trying to label the data. One of the supervised algorithm, and it is versatile algorithm. One of the versatile algorithm. Please forgive me if I'm writing something wrong. Versatile algo. Why it is versatile algo, guys? Because it perform best. It perform best in terms of classification, as well as regression for both the tasks, classification as well as regression task. It is going to do a awesome job, very high accuracy, very sophisticated things it has, and it is going to perform the same thing. Now, since we have spoken about it, and when I talk about the decision tree, guys, we can simply say whatever the data sets we have, whatever the data set or whatever the data we have, we try to divide the data. We try to divide the data in a tree-like structure, in a tree-like structure, just like the root node and leaf node, or you can say leaf node, or you can say parent and child node, parent and child, I can say parent and child node, and up to certain depth, like how deep we should create this tree, right? How deep. So it is trying to divide data in a tree like structure, guys, just like the format of root node and leaf node, or you can say parent and child kind of one thing. And then it will go up to certain depth certain depth, based on what is going to do, how it is going to decide that what it should be the depth, based on certain condition, until unless that condition is fulfilled, it will keep on going. And then, guys, then it will do its prediction. Then it will do the prediction, guys. This is all about, this is the overview. Then it will do the predictions, right? This is the overview. Let's imagine this way. Let's take example. What the example is, could be this way. So whether very, very favorite, very close topic to our heart, we're going to take whether the will India will win World Cup. This is our prediction we have to make now. All right. So this is the prediction we have to make, whether India is going to win the World Cup or not. World Cup. Okay. So World Cup fever is going on. So I want to understand whether India is going to win a World Cup or not. This is what I'm trying to do. Now let's understand that how the data set is getting divided into the tree-like structure, and how the decision making will happen, guys. So let's imagine this way. Now, guys, you have to help me here. You have to help me, guys. I know you guys are already deep into the topics. You guys are watching, following this entire World Cup. So, guys, what is the first feature I should take, or first condition I would say? What is the first feature or the condition I should look into? Okay. So to start this decision, guys, to start the decision, all matches still now won. Yeah, guys, this is what we can say. This is not. Yes, we can take that all matches are won, and that makes our prediction very strong. That is a supporting argument, but we can put it in this way. Okay, so let's put that condition whether India is winning matches or not in the let's frame it this way. Okay, I will go with this condition first. All team members are perform well. Awesome, sir. So awesome. Yes, all matches are won or not. So matches won. First criteria, matches won. So matches won, yes or no. Okay, matches won, yes or no. This is my, let's say, imagine this become my root node now. Root node, and this is where I started. Matches won, yes or no. If the matches are won, if India is not winning the matches, obviously stop. There are chances that we're not going to win. So we'll not win. No win, right? No win. We're going to stop. Now let's imagine the first condition that whether India is winning the matches or not. Yes, India is winning the matches. Then what? Then how should we decide how we go close? So Dharam sir is saying all team members are performing. So let's imagine this condition now. The performance of team members. Performance of team members. So are the team members performing great or good? Yes or no? Right? So if the team members are not performing well, obviously there is no chance. I cannot go further. The tree will stop here. Then if my team members are in good form, they are showing very good form. I am winning the matches. Whether I am winning the matches, yes or no. So that will decide. That is the deciding factor first. Then I decided that yes, if my team members are winning the matches, then what next? What next? Till now, my players are played well, and whether all of them are performing well or not, right? Performance of the team member, how it is. Very good. Yes. So then, guys, what? What next? What next can come into? Let's imagine now you reach to the final now. So in final, India will win or not. Now we have decided India won the matches. Yes, it is entered into final. Now my team members are doing good. Yes. Then what next, guys? What next will decide that India is going to win a World Cup or not? Let me tell. Let me think, guys. Let me think. What else now? Come on, guys, think it. Like opening partnership was good, less pressure on third down batsman. Okay. So this could be one thing. So guys, please try to think about the certain condition about the pitch condition, weather condition, the opponent team condition also. Please try to think in versatile way, like the decision tree will think. So how that gonna be on that day? Who is opener batsman? Awesome, awesome. Who is gonna be the opening batsman? Opening में पनौती लगे तो then difficult, right? If opening batsman fails, then very difficult. But we have a very strong bottom line. We have a very middle batsman are very strong. We have a very strong batting line, so it will not matter anyhow. But I try to understand certain condition like a pitch condition. We can also opening partnership. I say opening partnership or opening batsmen, whether they're going to perform well. If yes, then only I can think of it, right? Otherwise, the probability will be very less to win, right? The opening batsman, how they are going to do, right? So guys, let's understand. Though, so there will be no pressure. Opening batsman performing good, the pressure will be less, right? Pressure, no. Pressure will be no. Toss important. Awesome, awesome, guys. Toss is important. Now who is going to win the toss, right? So toss is important. Then Shami, Shami, higher wicket takers so far. So in the tournament depends on rain also. Awesome, awesome. So guys, before we go for the toss, we can think about the something called as pitch condition. Pitch condition or weather condition. Because if the pitch is, let's imagine you won the toss, but the pitch is going to support our weather. We can put all this condition in the weather. So whether that is going to rain or not, whether the pitch condition going to be a dew, there going to be a dew or not, or whether we going to bat first or not. If we batting first, then pitch should support us, or whether pitch is going to support the spinners after all. All this condition will be weather. Weather is supporting us. Yes. So we can go ahead and think of the winning chances are more now. If no, guys, we're going to stop. If no, we're going to stop. Everything will be on God's hand. We don't know. Everything will be fluke, guys. Then what? Pitch condition is good. Weather is supporting us. Now, opening batsman could be going very good. And our performance of the team till now very good. And we have done very nice performance. We have won all the matches. Now, guys, come on the last day. What is going to be a final winning conditions and what will decide one World Cup or not now. Last condition, last one or two condition, guys, please tell me, and then we'll try to end up our algorithm now because we are going depth now. Now you guys are able to understand like how we are going depth. So this depthness has to be understood, right? How depth we should go and up to what condition we should go depth, right? That is what also the decision tree will be doing. Guys, last condition, last few one or two conditions, please tell me. So what's going to be? Bowler performance, awesome, awesome. How the bowler going to do a performance? Bowler's performance, the all the captain engagement, awesome. Bowler, captain engagement, the moral of the captain, moral of the bowlers, the fielding players strategy, their morals, entire gonna make sense, right, on that day. How the people are pumped up on the day. And guys, you are forgetting one more thing. Obviously, us, the crowd. So whether we have a nice crowd, because it's gonna be rare, right? Previous winning history that teams has, right? So and one more thing, guys. Awesome, awesome, Roshni, man. Awesome. So try to understand how the crowd is supporting, how the crowd is there. If the very less crowd is there, there will be no enthusiasm. If crowd is fully supporting India, obviously there are high chances. Everyone's moral will be boosted. Body language, awesome. Crowd, body language, right? Support for the team, cheer ups, right? All these things. Guys, there one more thing you guys are for previous history, right? This yes, no will be stopping. And then previous history, obviously. Previous history of what, guys? But I will say previous history, not only in the previous history of finals. In finals, how India has performed in the previous World Cup, that matters on that day, right? That matters. Previous final World Cup history, like in the finals, how India has performed, right? That is very, very important, guys. And then obviously, the last condition is the yes, if condition has to, and then last condition has to meet is that opponent team has to fail, right? Opponent team should be failing this way. The Australia has to lose, right? I think health condition of the team. Yeah, awesome, awesome. Fitness. So I can say fitness and the opponent team is very important, guys. If opponent team is failing, that means there are very high chances we are winning. And this way we can lift the World Cup, right? This way. There will be more condition and this tree will go on, right? Tree will go on. Now, guys, try to understand. Subject to pressure, home ground, country expectation to win. Correct. Awesome, awesome, sir. So entire depth analysis you guys are giving me, right? So this was your close to heart topic and you guys are able to give me all the condition. Now look at our tree, guys. Now look at our tree, how it is getting, right? So we started here. We started here whether India going to win or not. So we understood like root node. Here first we understood how many matches India has won. That is very, very important condition. If India's performance till now is very worst, so we're not going to forward. We're not going forward, right? So no one would have expected that India will win World Cup this time. Since India has played so far so well, so we are having very, very high expectation, and then all the other conditions are coming up. Now, my guys, this is how the decision tree gonna go, and this is what I spoke about, that it is going to divide the data in the tree-like structure based on the certain condition, yes or no condition, and whether on the yes left hand side it will further get divided. Otherwise, we can stop, or we can also keep on dividing until certain depths we have gone. Now, guys, whatever things you have told me, like how many matches are won, this is one feature. Now, coming to the machine learning language, coming to the data science language, this is feature number one. So we have taken feature number one as a root node, guys. Root node. We have taken this as a root node now, and this is very, very important. There is very important decision we have to take before we start discussion, that what should be my root node? What should be my root node? That is a very important question. Where should I start? Where should I start? Right? So that is important question. Once we answer the question, everything rest thing will come into the picture. Rest thing will come into the picture. Now, first thing to start, guys, to start my journey, embark this journey of the decision tree, it has to understand out of my all the features. Like feature, we understood team performance, how many matches won. This was the second root node. This was the second feature. Then batsman was the third feature. Opening batsman, they are high in pressure or not. Then the feature number 3 was pitch condition, right? Feature number 4, and then we have a how the bowlers are performing. Feature number 5, and then how whether we going to win the toss or body language and all things. And this is feature number 7, 8, 9, and the opponent team failing, and so on. Let's say 10 features. We have a 10 feature. Out of this 10 feature, my question goes to you guys. So which one is important now? Which one is important? Where we should start? Which one become the root node? Root means where to start, which feature will take first, and then we'll divide that feature based on the condition, and then we'll try to understand the next condition based on that, right? So here we took like how many matches won, or till now India has won all matches. That means India is winning so far or not. So that kind of a condition was very important. We have given importance. Now in real time, when we have a multiple features in our data set, whenever, let's imagine this way, in the real time, if I have this kind of a conditions, so let's imagine I'm trying to predict a diabetic prediction, or let's imagine I'm trying to predict the BMI. I'm trying to predict the BMI, and for BMI, I have a kind of a equations like age, I have a height, I have a weight, I have a gender, I have a food pattern, how what kind of a food I am eating, and all these features are there, and based on that, all these features will be my X. So based on this X, I have to decide what is going to be my BMI number. BMI number, this is my prediction. So guys, here, in order to create the decision tree of BMI prediction decision tree, I have to first choose the root node, the starting point. So where I should start, which feature will come into the picture, and where should I start first, right? So that is going to be a very important decision which I have to make, guys. So which I have to make, and decision tree try to think this way. Decision tree try to think in this way, guys. So before we start understanding, how the root node will start, and how the this is all about the classification task we are talking about. This is all about the classification task we are talking about, classification, whether India is going to win or not. So before we enter into the classification and we decide like which feature will come and which feature should be chosen first in order to create a decision tree, guys, try to understand in regression task, in regression task, how the decision tree will happen, how the decision tree will perform, and how the decision tree going to behave, what is the entire working of the decision tree. Now let's imagine the regression task we are having and in hand today is how much score we have to predict the score of India in the final. How much score India will do in the final. Okay, score of India in finals, in World Cup final. So this is the number, obviously. So this is number. This means it is a regression task. So we have to predict this score now. So let's imagine for predicting the task, guys. So for regression purpose, now my algorithm decision tree, it has a two type of, let's imagine this way. It has a two type of approaches or two type of algorithm, guys. One is a normal decision tree regressor, normal decision tree regressor. So in normal decision tree regressor, guys, what I have to do is, or what this going to do is try to understand whatever data is there, guys, whatever data set or whatever data I am having, all this data is get divided, guys. All this data is get divided into, let's imagine, J distinct region. J distinct. Please try to understand carefully what I am trying to say. Distinct. J is number, some constant number. So J distinct kind of a regions first. I'm going to divide my data into J distinct region. Okay. So whatever data set, let's imagine capital X is my data set. So all X1 to Xn data set, whatever n number of data set is there, all this will be getting divided into a J distinct regions, J distinct region. And this way it is going to divide the data into the distinct region and the non-overlapping region. Non-overlapping region. Non-overlapping region. So means what? Non-overlapping and distant region. Can anyone explain? Like what is your understanding when I am saying non-distinct and non-overlapping? Non-overlapping. What does that mean, guys? What does that mean? Can anyone quickly tell me? Can anyone quickly tell me, like, what do you mean by non-overlapping and distinct? What is going to be regions? We're going to divide the data into some regions, some kind of a regions. Okay. So J regions. So region could be this way. Region 1, region 2, region 3, and so on till RJ, region J. Okay. So can anyone tell me very quickly, guys, very quickly. So what do you mean by non-overlapping? What do you mean by distinct now in this case? How it's going to look like then? When I say distinct or non-overlapping, what is the idea then, guys? Anything coming to your mind, like what could be the problem? What could be the situation that it will be called as distinct or non-overlapping? What will be the property this region will be carrying then at that time? Try to understand if this is my entire data set, guys. Okay, this way. Let's imagine this is my entire data set. So this entire data set, when I'm trying to perform a regression task, guys, I'm going to divide them into distinct unique data. Yes, guys. Awesome, awesome. Unique data in each region, guys. That's what I was looking at actually. So whenever I'm trying to divide this data, guys, into the number of region, let's imagine this is one region. This is the second region. This will be the third region. This will be the fourth region. This is fifth and so on, guys. So, but every data point will fall into one of the region. And this data point, whatever data points are available, let's say imagine region 1 will not be present in region 2. So region 1 will not be equal to region 2. So everything will be distinct. Okay. This is what we are talking about now. That means whatever data points are there in the region, they are individual to that region. They are not repeated anywhere, right? So what we're going to do is, first we're going to divide the data into n number of j number of regions, and this n number of data points we have, n data points we have, and we are going to divide this n data point into j regions now. And what I have to do, guys, I have to divide the data in such a way that divide the data in such a way that, guys, so I follow the sum of square residuals rule. Sum of square of residuals. Sum of square residuals has to be minimum. Now try to understand what is the sum of square. Sum of square will, guys, so whatever that individual data points is there, from that data point, okay, distance from data point, from the you can say mean, from the mean of that region. Okay, so region could be like RJ. I am saying RJ, region J, region 1, 2, 3. So I am calling this for now first region. Region J will be there. So region J will be something from 1 to n. So whatever the centroid of that region is, let's imagine this is the centroid of region 1. So all the data points, the distances of all the data points which are present in that region, okay, so that distance should be minimum. Actual data point minus the centroid of data points. Okay, that region should be minimum, and this is for all the data points. This I just wrote it for one equation, one single data point. So RJ I am writing region 1. Let's imagine this is region 1. So I am writing J. So J could be 1 to n, whatever regions we are creating. So I am writing this way, and this is 1 equal to I equal to 1 to n. N is one number of data point, and this I have to square, guys. I have to square because to nullify the effect of positive or negative differences. Okay, and then I am putting double summation sign. Right? Try to understand what is this double summation sign. Double summation sign for, guys, this situation has to be true for each and every region, right? Each and every region. So the same situation should be true. So that's why I'm saying I equal to, not I, actually J equal to 1 to whatever m, 1 to m or 1 to whatever G, this J regions, right? So the J value could be like this way. J value could be 1, 2, 3, 4, 5 up to m, and this n value, whatever the data points we are having, could be from 1 to n. Okay, 1 to n, whatever data points are. That's why I'm writing double summation sign, guys. And this is called a sum of square residuals. Sum of square residuals, and this has to be minimum. This has to be minimum. In such a way, guys, in such a way, I have to divide the data. Decision tree will do this way. Decision tree, okay. And then once I divide, guys, so what's going to be my prediction? That's the next question now. That's the next question. So what's going to be my prediction, guys? Prediction will be the average mean. Okay. So whatever the mean we have, this mean, whatever distances we are taking, whatever the values are present, the mean of that region will become my prediction. Mean of that region will become my prediction, guys. This is what going to happen. This is first. This is the first approach actually, and there is something. One more approach is there. Binary recursive binary splitting. Recursive binary split. Binary split, guys, and this is very famously called as a greedy approach. A greedy approach. Greedy approach. And this is the second approach which they follow in the regression, guys. Decision tree regression. In greedy approach, what they're going to do is they're not going to divide the entire data into the n number of regions. Okay. So whatever this data is there, they are not going to divide the data into number of regions. They're going to divide this data into only two regions, guys. Only two regions. In such a way that, again, the same thing. In such a way that all the regions differences from the center to all the points should be minimum. All the points should be minimum. So this way. So let me write that they're going to divide the data into the region. So I'm going to write the same equation, yi minus this y bar. So the centroid, you can say, the square, and this is for region 1, R1. Okay. So this is summation for all the data points which are present in those regions, I1 equal to n, and then plus for region 2, yi minus y bar is region 2 whole square. And this is the summation sign for the second region for all the points. And this has to be minimum. This has to be minimum. And then once we divide this region, guys, whatever the center is there, average of all the values, within that region. So will be the prediction, will become the prediction, guys. Will become the prediction for the decision tree regression. Okay. So this is what the approach they will follow. Obviously, there will be something called as pruning, which way they try to regularize the things. I will talk about it. Then, guys, we try to understand that now the question, obvious question, which will be coming to my mind will be like why I am trying to do this binary or why it is called as greedy approach. Why it is called as greedy approach? Why not it is trying to divide into n number of regions and then trying to take, which is a better approach actually. So similar points will get into the similar regions, and that's how it will become very easy to create a kind of a prediction for us. So now try to understand, guys. It is called as greedy approach because rather than now try to understand, rather than waiting for the best criteria, right? Rather than waiting for the best criteria, or you can say criteria, or you can say best feature. Criteria could be a feature here because whatever decision tree we are doing is based on the features, number of columns, whatever columns we are having. Rather than waiting for the best column or criteria to split the tree, guys, to split the tree or split into such region, it will try to go. It will try to go recursively. It will try to go recursively, and it will try to whatever the feature comes in first, it will try to split on that, and it will not wait for the best feature to come in. And rather than choosing the best feature, so it will go recursively, and it is trying to be a greedy one. So that's why they call them as greedy. It is very greedy to eat that feature. It is kind of a greedy to eat that feature, right? So it is not waiting until the end, so that I can find out the best feature, and on the basis of the best feature, I can divide this data into the region. No, that's what not doing. So that is why it is called as a greedy approach, guys. Greedy approach, very famous concept, greedy recursive binary split, or you can call this as a recursive binary split, guys. Recursive binary split. Okay, so this is what the regression look like. Now coming back to the feature, coming back to the question, when in classification, when we try to decide the tree. So here also, guys, in regression also it is going to do the tree, but it is going to divide in such region wise data, and then it will try to build a tree. Now coming back to our equation, that when I am trying to predict the BMI, and what are the feature I should use first, whether I should go for age, whether I should go for height, I should go for weight, I should go for gender, food pattern, which will become my root node. Any clues, guys? Any clues? Any idea? So what decision tree would be doing in order to choose one of the best out of this, and then it will try to understand that this is my starting point now. Which feature will become starting point? Any clues or any idea, like how it will try to do, or what will be coming to your mind, like how can we do this one? How to perform this splitting? Weights. Okay. So Roshni, ma'am, please, can you like age? But guys, weights or age, like, can you guys please tell me your preferences? Like, what is your logic taking like weight or age? Like, what is your logic here? Why you are taking this one? What is your logic? Like, why you think that we should take age or we should take weight here first? Any clues? Like, can you please give me a bit of a logic? Like, what logic you use to decide to come up with this is what we should take first? This feature. Yeah, guys, come on quickly, fast, so we can start understanding. What is your logic? Like, can you explain the logic behind it? Like, why you're taking age or why you're taking weight? Like, where to start at the root node? As a person gets aged, weight tends to increase. Okay, awesome, awesome. You are trying to think from the logical point of view and understanding the logical relationship between the features. But now for my machine learning, guys, that is very true. Like, since that is the difference gap between the machines and human. Human can think like this way, but my machine cannot think. Machine learning algorithm cannot think in this way, right? So that's the actual problem for me. Okay, guys. If the entropy awesome, awesome. So deep, sir. So awesome. Okay, we can select a root node. Now that's what my question. Next question was. So my machine learning algorithm cannot make a decision, region-wise decision, a logical reasoning cannot be done by my machine learning until unless I time them vividly. So this is the logic. Please follow this logic. They cannot understand. They cannot think like the human being, right? Like you guys are thinking, as the person age gets aged, he try to get age, his weight tend to increase, or could be decrease also, could go vice versa also, guys. I guess to start with the first feature, Baswaraj. Awesome, awesome. So guys, not this way, not this way. So yes, Sodip sir, your understanding is correct. So let's try to understand. That is why machine learning, the machines cannot understand the logics. Logical reasoning part is missing, guys. That is why we are artificially giving it we are giving it as an intelligence, right? Artificially, we are feeding it an intelligence. That is why it is called as artificial intelligence. The inborn intelligence is missing, guys. Let's try to understand now the criteria out here. I will not waste your time. I want to give you criteria first because we have to start the discussion also for artificial intelligence. Sorry, for the artificial neural networks. So guys, try to understand what's going to happen. There are two criteria to decide. One is called as entropy. One is called as entropy, guys. And second is called as Gini impurity. Gini impurity. Gini impurity, and try to understand what's going to happen. So after we calculate the entropy, guys, after we calculate the entropy, after calculation of the entropy, we going to calculate something called as information gain. Information gain, okay, that's what we're going to understand first. So information gain will be calculated, and if the information gain is more, if the information gain is more after splitting, after splitting the tree on that particular feature, then we're going to use that feature as our root node. That will become your root node. Then that is the law, that's the rule. Okay, so we calculate entropy first, and based on entropy we're going to calculate something called as information gain. If my information gain is more after splitting the decision tree, after taking that node and splitting my data based on that feature, if my information gain is more, so I will go for that feature. Otherwise I will not go for that feature. That's how it is called as. And then Gini impurity has which will be between, guys, 0 to 1. So whosoever give me less Gini impurity, whosoever give me less impurity, that will become my root node. That will become my root node, guys. That's how it's gonna look like. So let's understand one by one what is this entropy and how to calculate information gain. What is this Gini impurity? Okay. So guys, entropy. First thing is called as entropy now. Okay, what do you mean by entropy? Very simple thing. Well known definition for entropy, guys. Entropy is a measure. Is the measure of randomness. Measure of randomness or measure of impurity in the data. Impurity in the data, guys. Measure of randomness or impurity. Impure. How much data is impure? How much is the impurity in the data? Impurity of the data, that is measured by the entropy, guys. That is measured by entropy. Now what do you mean by measure of randomness and what do you mean by measure of entropy? Let's understand this way. So let's imagine this is what the data looks like. This is what the data I have. So in that data, let's imagine this kind of a data set is there. And there is one more data set, and I'll try to compare this data set with you guys. And then we'll try to understand what do you mean by randomness, what do you mean by impurity in the data. So obviously this circle will become class 1, and let's draw something like this one. Okay, and let's draw this way here. The triangles become the class 2 now here, class 2 now, and let's imagine this way. Guys, now out of which can you guys tell me like which one is more pure, which one is more pure, and which one is less pure? Purity. Okay. The diagram number 1 or diagram number 2. Which one is more pure and which one is not pure, guys? Can you guys tell me, like looking at this picture now, which is more pure and which is not pure? Look at the graphical presentation and try to come up with a conclusion that which is pure, which is not impure. Which is impure actually. Diagram number 1 is this, diagram number 2 is this, guys. First one more pure, right? So guys, now sir, can you please tell me the logic, like why you decided that first one is pure and not the second one? Yeah, simply, Basavaraj sir, please tell me the logic. What makes you think that first diagram is pure and why not the second one? That's it, and then we are done with the entropy concept. We'll understand what do you mean entropy then. Hey guys, any other guesses, like anyone else having any other opinions? Which one is pure and which one is not pure? Only one or two color data. Awesome, sir. So let's imagine this way. Apart from this portion, okay. So entire data belongs to the class. Entire belongs to the class 1 or class circle, okay. And this is the class 2. So if I want to say that my cluster, my data is pure or impure, okay. So that means whatever data we have, whatever data set we have, whatever the data we have, if it has the same class, if it has the same class, okay, if it has the same class, then it will be called as pure. It will be pure. And if it is a mixture, of all the data classes, mixture of all the classes, or you can say labels, all the labels, guys, it will be called as impure. Okay. That's how it's gonna be. Okay. So this entropy, it measures the randomness. Randomness means This is not random, but this is very random data, random data. So many classes are present cluttered within each other, wherein the first one, this one is having very pure data, but you try to understand, guys. This is decided by the density actually. This is decided by the density. There is an actual density concept in the physics by using which, like imagine this kind of a cylinder, this cylinder, okay, cylinder. This cylinder, guys, whenever we try to understand, this is a cylinder. Let's imagine this cylinder is filled with the nitrogen cylinder, right? This physical concept, nitrogen cylinders. So this nitrogen cylinder, they will try to understand whenever we have a cylinders which are filled with the nitrogen, guys. These kind of particles are there, and then in the nitrogen, guys, obviously I don't recall the formula for the nitrogen now. So this nitrogen, this filled with the nitrogen, imagine at that time, guys, based on the density, guys. Obviously, in the entire density, measurements in this cylinder, guys. So the nitrogen portion should be more. And very few oxygen portion should be there. Very few oxygen portion should be there. O2 portion, oxygen portion should be very few. And entire nitrogen, NO2, I think something that I don't remember the nitrogen formula. So nitrogen formula has to be there. So nitrogen has to be more, oxygen has to be less, guys. That kind of a density has to be more. The density for nitrogen should be more. So then it will be called as pure. Then it will be called as very, very pure. Okay. So this physical concept has been brought here, and then try to calculate the entropy, guys. And simple formula, guys. Simple formula for entropy is there. So if you want to calculate entropy, let's imagine the P is the probability. So P is the probability. Let's imagine you have a n number of data set. N number of data set in your data. Number of data set is n. And then let's imagine P is the probability for class 1. P is the probability class 1. And out of this n data, m data points are available which are belonging to class 1. So obviously, whenever I try to calculate the probability for class 1, I'll try to calculate it this way. Number of favorable event divided by total event. So my total event will be, favorable event will be m. The total event will be n, guys. M by n. So this is what my P will be there, P1. So which is belong to probability of class 1, guys. So if P is my probability class 1, obviously 1 minus P, okay, 1 minus P, which is Q, guys, will be the probability for other class, right? Will be the probability for other class 2, right? This is what is going to happen now. So this way, if I try to calculate, the entropy formula, guys, E entropy will be given this way. Okay. So it is minus P log minus P. P is the probability of class 1. Log P minus P log P, but base is 2, guys. Base is 2. Okay. Minus Q log Q base 2. Okay. So this is the formula, guys. This is the formula for entropy. And you have to calculate the entropy this way. And once you calculate the entropy, guys, you have to calculate the information gain. Information gain will be, guys, this way. If the T is the decision tree and X is the number of splitted after splitting the tree, it becomes T of X, TX, this way. Okay. So this is what I am calling. So what is the gain? So what is the gain of the tree when I try to split that after on the feature called as X, on the feature something called as X now. Okay. Something called as X. So that is the gain we are trying to calculate. So gain will be like entropy before splitting the tree. Okay. Entropy before splitting the tree. And then we try to calculate the entropy after splitting the tree, guys. Entropy after splitting the tree on the basis of the feature X. Okay. So that difference of entropy will be called as gain, guys. Information gain, IG. Information gain for the entire tree. Okay. Why use log 2? Okay. That's the formula the guys have developed, right? So log 2 formula. Actually, I have never thought like why they are using, but I'll try to come up with the logic, guys, why they are using log 2 here. I will tell you, guys. Okay, logic. I read once. I don't remember exactly, but I will get back to you guys in tomorrow's session why they are using log 2 here. So they have decided that the entropy will be calculated by this way. They are statisticians. They can do anything. Like we can do also our own formula. So this way, guys, P minus P log 2 P base 2 log P. P is the probability class 1 probability, and Q is probability for class 2, guys. Q is the probability for class 2. Okay, this is what it's going to be. And then once we calculate entropy, guys, you have to calculate the gain. What is the gain of splitting on the basis of feature X Before splitting, after splitting, what is the entropy? That entropy difference is called as information gain. If the information gain is more, guys, information gain is more, that will become my root node. That will become my root node, guys. That's how it's gonna be. Now, this is the one measure, guys. This is one measure, and the second measure. Second measure is called as Gini impurity. Gini impurity. Gini impurity, guys. So Gini impurity says, guys, Gini impurity says this way. Try to understand. Gini impurity will be telling you is, so what is the, let's imagine this way. If I try to take the data set, if I'm taking one data set, if I'm taking one data set and I'm choosing one random variable, I'm choosing one random data point out of that, one random data point, and I'm trying to classify it. I'm trying to classify that data point. I'm trying to classify. If you try to look at this definition, guys, online also you'll find the similar definition. But I am trying to make it very simple for you guys. Let's imagine if you have a data set. Out of that data set, if you choose one random data point, and try to classify it randomly. Try to classify that data point randomly, okay, randomly. Then what is the probability? What is the probability? What is the probability that it will get misclassified? Or what is the probability that, that it will be classified, it will be classified incorrectly. Classified incorrectly. So that is called as, guys, this measure is called as Gini impurity, guys. Gini impurity. So Gini impurity said that if you try to take a data point, if you try to take an entire data set, out of that, if you take one point, and try to classify it randomly, and that random selection has been done, and you are trying to randomly classify it. So what is the probability? What is the probability that it will get misclassified or it is going to get classified incorrectly? So that measure is called as Gini impurity, guys. Gini impurity. And to calculate the Gini impurity, guys, you have to perform a multiplication. So you have to sum. Okay. So it is kind of a, it will be told this way. So what you have to do is, in order to create this kind of a Gini impurity, you have to sum, or you can say multiplication of. It is a multiplication of. It is a multiplication of probability. Multiplication of probability of correct classification. Correct classification. Okay, and correct classification and summation of all incorrect probability. All incorrect probabilities. Incorrect probabilities. Okay. So this is what they talk about. So this says that what you have to do is, so the formula, guys, the formula will be this way. So let me tell you that if we try to calculate the Gini, the formula will be 1 minus summation of p square, summation of pi square. Pi is like 1 equal to I equal to 1 to C, and C will be incorrect classification, all the incorrect classification probabilities, summation of all incorrect classification probabilities into summation of the correct probabilities. So this kind of a formula is taken, multiplication. So then when you try to solve the formula, guys, you will get this kind of a formula, Gini impurity, 1 minus summation of pi square. Summation of pi, this pi is, guys, incorrect probability. So you can ask, obviously, like, how we try to achieve this. Okay, how we try to achieve this one, right? So let's imagine this way, how they are, but my definition says that it is a multiplication. My definition, what it says, guys, it is a multiplication of multiplying the probability of observation, or probability of correct class observation into sum of all incorrect probabilities. Right? Sum of the probability that it is classified into the wrong class. So let's imagine this way. Okay, so let's call this P, this pi, as the probability of correct class classification. Okay, probability is given by correct class classification is given by pi. Okay, so obviously if I have pi is the correct class probability, guys, so probability, let's imagine this way, probability of a correct classification. So 1 minus pi will be, guys, incorrect classification. incorrect classifications, incorrect classification probability summation, right? So 1 minus pi will be the summation, because whatever incorrect classes, because the probability has to lie between 0 to 1, right? 0 to 1. This is our range of the probability. So if I say pi is the probability of correct classification. Correct classification, obviously 1 minus pi will be the summation of all incorrect probabilities. So on probability, let's imagine as per my definition, Guinea impurity, as per the definition of the Guinea impurity, guys, Guinea impurity, I am going to do the same thing. Let's what my definition says. Multiply the probability of correct classification into summation of all the incorrect classification. Summation of all incorrect classification, right? Summation of an incorrect classification. Summation of I equal to 1 to say n or c, not n. N is actually all the data point. So pi into incorrect classification. What is my incorrect classification? So incorrect classification will be 1 minus pi minus pi, right? This is what this is, right? This is what this formula actually be. And let's try to understand what's going to happen. And this is also the correct classification, right? This is going to be a summation of all the correct classes into summation of all incorrect classification. Okay, so this way. So let's imagine, let's try to evaluate this formula and try to understand that how it's gonna look like, Okay, let's imagine this way. If I try to take the summation side sign outside, then pi into what will happen? Pi into 1 minus pi, pi into 1 minus pi. This is what it is gonna look like, right? So let's evaluate this one. Let's evaluate, and then so same thing if I try to look at is pi into pi, pi into 1. Pi into 1 will be pi minus pi into pi square. Pi square, right? Summation sign as of now I am keeping aside, guys. So let's imagine this way. Pi into pi square, right? So guys, when I say pi into pi square, right? Pi into pi square. So let's imagine again, come back with summation of this probabilities. Pi minus summation of I equal to 1 to c pi square. This is what it's going to look like, right? This is what it's going to look like, right? So if I try to put a summation sign back with them, right? Correct probability into probability, yes. But try to understand when I say pi, guys. So pi incorrect probabilities in the correct probabilities. Let's imagine that correct probabilities. This will be replaced by 1, because they think that whatever the correct probabilities are there, pi probabilities, this pi's value will be evaluated this way, right? So pi's value will be evaluated this way, like whatever the pi is there. So pi, let's imagine this pi, the correct class classification, probability of correct class classification. So this pi is, let's say, class 1 probability. Okay. So then now they're trying to think this way, the classification of class 1 and classification of class 2 now. So okay, class 1 and class 2. So this is the correct probability. If the correct probability, guys, if we try to do this way, this will understand this way. If I try to do, let's imagine if I'm trying to do a classification, if I'm trying to do a classification task, and if I do a correctly, if I do my classification correctly, so it will be called as 1. It will be called as 1. If I try to do a wrong classification, it will be called as 0, guys. It will be called as 0. 0 means wrong. 1 means correct, right? 1 means correct. This is what the background calculation happens, right? And this is what they try to even compare the categorical variable, guys. So whenever, let's imagine that I say the class, let's imagine this way. So it will become, whenever we try to calculate the loss, guys, categorical loss, I'll tell you guys this way. Let's imagine that you are trying to do a classification of dog and cat. Okay. And this is your prediction, y hat, and this is your actual prediction, actual. So if your algorithm says it is a dog, so it will call the dog as 1 and cat as 0, right? This is what you try to indicate. And in reality, guys, if it is not a dog, actually, it is a cat. So this is what it will look like, right? Dog will be 0 and cat will be 1, right? This is what it will try to indicate in terms of the vectors. So these are called as vectors now, vectors of the classification. And then you have to understand the difference, guys. So how they will try to calculate the difference between actual and predicted here. Loss function is, if my category says dog, the prediction says dog, but actually it is not dog. So there is a difference, right? 1 minus 0, the difference will be 1. And this is also the difference, right? This is also the difference, because actually I saying there is no cat, but in reality is a cat, right? So cat is 1. So difference is 1. So my loss will be, guess, summation. Summation will be 2. So my loss, categorical loss will be 2 now. So this way they try to calculate. So similar thing they try to put it here, guys. So correct class classification means 1. So they try to put 1, and then summation of I equal to 1 to c all incorrect probabilities. So this is how, if I try to evaluate, this will become my Gini formula for Gini impurity, guys. Gini impurity 1 minus summation of all pi square, incorrect probabilities. Okay, same equation I have written above, right? So same equation. So this is how they have evaluated, and they have come to the Gini impurity, guys. Alright, guys. So this is called as Gini impurity. On the basis of this, guys, on the basis of this, it will try to follow. If you guys want, I can simply give you one example this way. Otherwise, it will take much time, guys. I will share with you like one calculation, how manually they have calculated. They have taken one data set and they manually calculated the Gini impurity in entropy, and then they decided which root node is good or bad. That kind of a notebook I'll share with you. If you are more interested in the background calculation, we can understand that calculation and we'll try to understand that things, right? Okay. So don't worry, I will try to share that kind of a notebook with you, notes with you guys. Okay. So guys, the last concept in the decision tree, what we have to understand is something called as tree pruning. Tree pruning, guys. Tree pruning. Okay. So I hope guys everyone understood. Everyone understood before we try to understand what do you mean by tree pruning method, pruning. So everyone understood what is Gini impurity, and what is entropy, and based on the entropy, guys. So we try to calculate. Okay. Okay, guys. Thank you. Thanks for the confirmation. Okay. And based on the entropy, guys, we try to calculate the okay, guys. Basavaraj sir, Rakesh sir, thank you. Thanks for confirmation, guys. Once we calculate entropy, guys, after entropy, you have to calculate something called as information gain. So if you try to split your data set on basis of that particular feature, so what is the entropy before and after the splitting? So that difference you have to calculate. More the entropy, guys, more the information gain, better the chances that it become a root node. And it is opposite, guys. It is opposite in the Gini impurity. Gini impurity, we have to calculate this way. Incorrect classification minus summation of all incorrect classification, 1 minus summation of any incorrect classification. If Gini impurity will be given in between 0 to 1, it is more towards the 0, the better the chances that it become a root node. Better the chances that it become a root node. That's what we have to evaluate, guys. Then, guys, something called as tree pruning. So let's imagine this way. Tree pruning is nothing but, guys, a regularization factor. Regularization factor. It is a regularization factor, or you can say this is also a penalty. Like in regression, we have a L1 penalty, L2 penalty, and no need to explain, right? Why we try to do a penalty, guys. So when we have a something called as overfitting situation, guys. At that time, we have to introduce this concept of the tree pruning. And can you guys like anyone can you guys tell me like what is the concept of the overfitting? Actually, there are two concepts. One is underfitting and one is overfitting. So sometimes model try to overfit and sometimes guys try to underfit. So can anyone tell me the difference between overfitting and underfitting very quickly? So we have to end up this discussion and start the artificial neural network today. So very quickly, if you guys can tell me, anyone having any clue, any faintest idea, like what is this overfitting and what is underfitting? So that will be great, guys. So we can understand this tree pruning, why we require tree pruning, why the regulation concept is required in the decision tree, guys. Very quickly, guys. Anyone? Any clue? What are you overfitting? Can you guys explain in one-liner explanation? What is underfitting? What is overfitting? If anyone aware. So I can have some breather. I can drink water. Meanwhile, you guys can reply me. All right, guys. So we have one answer. Roshni ma'am is saying overfitting means accurate prediction. Not exactly, ma'am. Overfitting means accurate prediction. Not in this way. You are close. You just missed by inch, guys. Any other ideas? Guys? It has to do with the prediction only. It has to do with the accuracy only. So, but try to understand. Try to think something else. Guys. It is about the accuracy only. But it is about the when we are trying to calculate the accuracy. Any other suggestion, guys? Any other ideas? Anything else? Anyone having any in their opinion, like what is overfitting, what is underfitting? All right, guys. So without wasting time, let's understand what do you mean by overfitting. So guys, understand overfitting means what? Overfitting situation. So what is overfitting? Let's understand this way. When we try to build a model, I showcased you the entire life cycle of the model building. So when we try to build a model, guys, first what we try to do is we try to do a entire data set. We try to split the data set, right? So some major portion will be provided to the training, and some portion will be kept it in the testing. Guys, what people can do is they can perform this way also. So they will try to do testing, then they will try to do training first. Some portion will be kept for training, let's say 70%, not 70, like you can say 80% portion in the training, 80% of the data. Then they have something called as test. So they will try to keep a 10% data in the testing, and they will have something called as validation as well. Validation, and they will try to keep a 10% data in validation. So what they're doing, they're just doing the testing only, but they are doing testing in the two phases just to make sure that their model is very accurate. Okay. So try to coming back to our situation. What do you mean by overfitting? Let's imagine whatever data set I have, whenever I try to build a model, I try to apply my half data, or not half data, at least 80% of my data into the training phase, and I try to train my model. Guys, once I train my model, guys, I'll try to check my accuracy. I'll try to check my accuracy of the model. Okay. Now look at this situation now. What is happening here? So I am writing here overfitting situation. So here I'll write something called as training and something called as testing. And what we try to do is we try to understand the accuracies. What are the accuracies during the test and what is the accuracy during the training? Let's imagine this way. When we have a overfitting, guys, when we have a overfitting situation. So in training, guys, my model fitted very well, and it is giving me back 95% of the accuracy, 95% accuracy. And my testing phase, guys, in my testing phase, it is dropping down very sharply, and it is giving me 85% of the accuracy. If I try to put it in this way in the graph, guys, this is what it's going to look like. Let's imagine we are taking accuracy out here. So this is accuracy, not accuracy actually here. So here we are having accuracy. Accuracy here will be the model complexity. Model complexity. Okay, model complexity. So guys, what will happen is, let's imagine this way. So this is accuracy level, and this accuracy is 1 here, and this is like 80, this is like 60, 40, 20, so on. Okay, this is 1. Actually, what is happening is, let's imagine this way. So training is giving me this kind of accuracy, and let's understand the testing phase now. So for testing, guys, it is giving me this way. Now try to understand what is happening actually. So this bar goes to 95, and this bar is for 85, guys. So means this has a huge difference out here. The scale of 10 difference. Okay, this kind of a difference when our training is very good. My accuracy during the training is very good, but in testing, guys, in testing, my model is dropping very fast, and it is giving me a difference. This kind of a situation, guys, this situation called as overfitting. Overfitting. There is a there is a large difference between the accuracies of the training and testing. Means my performance of the model is varying in the training and testing. It is not consistent. You can simply say it is not consistent. It is not consistent means your model is not robust, guys. Robustness of your model is not there. Your model is behaving very you can say your model is behaving in a very large variance. In the large variance, you can say your model is behaving in the large variance way. So variance is very high. Now, if the same situation happens, so let's imagine this way. What do you mean by underfitting actually? So underfitting means what? What is going to happen? In underfitting, as underfitting as. So in underfitting, my training data and my testing phase, both the time my model is failing, as both the time. It is 60%, here it is 65%. So everywhere in training phase, in testing phase also, my accuracy is very less. My model is failing at both the time. It is giving very low accuracy. So that is called as underfitting. Yes, my model is not able to fit to the data. That's why my accuracy is not good, or my consistency is not good. My model prediction is not good. That is called as underfitting, overfitting. Now, when we have, and then from graphical point of view, guys, it will be like this way only. So guys, actually what I have to do is, what is my ideal situation? If this is a mark of 90, this is a mark of 80, this is a mark of 60, this is a mark of 40, this is a mark of 20. My ideal situation, guys, it should be this way. If this is my training accuracy, my testing accuracy should follow very closely to it. So this is very ideal situation. Both the accuracy is going hand in hand, right? So this is what the model idealness should be there. If this is not happening, guys, then I have to call something called as regression factor. I have to introduce some kind of regulation, some kind of a penalty I have to introduce, guys. And that penalty is called as tree pruning. So there are two pruning, guys. One is post pruning, and something called as pre pruning. Pre-pruning. So guys, in post pruning, what is happening? First, we try to create. In post pruning, guys, in post method, we first we build the entire tree. First, we build the entire tree, guys. The entire decision tree is built upon. And then, guys, whenever we try to have a overfitting situation, then what we going to do? We try to cut the branches. We're going to cut the branches of the tree. Cut the branches, some of the tree, which are causing a overfitting, guys. This is what is going to happen. We trying to find out, and we are trying to cut the some branches. We try to cut a breadth of this decision tree, okay? And in pre-pruning, guys, in pre-pruning, before generation only, before generation of the decision tree, or while the generating the decision tree, guys, we are going to cut, we're going to cut the unnecessary branches. Unnecessary, okay? Unnecessary branches of the tree. And this is how we're going to create a, or we're going to avoid the situation of the overfitting, guys. Overfitting. And we're going to regularize, or we're going to give a penalty to our model. So that is called as pruning, guys. Pruning method. Post pruning, pre-pruning, and the pre-pruning, post pruning method will be like this way, guys. Whatever situation is there, actual minus predicted whole square. So whenever we try to calculate the loss function, guys, so at that time they will try to add something called as a lambda or alpha parameter, and then they will try to add this kind of a penalty, tree penalty. This is also called to be a L1 penalty, L2 penalty. So guys, this is my loss equation, plus they will have some kind of a regularization parameter alpha is called as regulation parameter, plus this will be something related to the magnitudes of the tree, and this kind of a equation is added, guys, with my loss function, okay? This kind of a equation is added my loss function, and this is how I try to regularize my tree, guys. This is called as pre-pruning, post-pruning, either before the generation or while generating the tree, or after generation, guys. I try to cut the branches of the tree, and I cut the branches of the tree means, guys, in real time, some features are modified. Some features, some columns, they are penalized on basis of their magnitude, so that there is no overfitting. Okay, that's what's going to happen, guys. And the last concept before we start our artificial neural network is, guys, something called as, guys, everyone comfortable now? What is pruning? What is regulation? What is overfitting? What is underfitting? Any questions? Any doubts, guys? As of now, everyone comfortable with this concept? What is going to happen? What is going to happen? Why overfitting is happening? Why underfitting is happening? What is the difference between them? How to identify them? All right, Kazi, ma'am, Kazi Bashir, thank you for confirmation, guys. So let's understand the last concept, that is called as random forest now. Random forest. Now try to understand the beauty of the random forest. What is going to happen? What is the beauty of this random forest? Try to understand this way. So what is going to happen? Random forest. So the name suggests, guys, random forest. The random forest is nothing but, guys, this is the collection of the trees. So whatever trees are there. So decision tree is a simple algorithm, it's an individual algorithm. Instead of one decision tree, guys, I'm going to take the multiple decision trees. Multiple decision trees, guys. Multiple decision trees are taken together. So they are going to combine the multiple decision trees. Then, guys, they're going to do a prediction. Then they're going to do a prediction. That is called as, guys, this method is called as random forest, but this approach is called as ensemble approach, guys. Ensemble learning, ensemble approach, or ensemble learning. Ensemble learning simply says, guys, if you could remember the KBC show, in the KBC show, guys, you have something called as voter's choice, right? Audience poll. Something called as audience poll, right? Audience poll. And what happens is, guys, whenever the contestant is confused, he will go to the audience. He will ask that, please vote for the votes, right? Please vote your, please make the voting for your this kind of a, sorry. So this kind of opinions are there. So these options, so please vote for the option which you think that the correct one. And then what happens is, people try to give a voting. That which one they think that is the correct answer. And then, guys, what happens is, whatever the vote is there, maximum voted option will be taken, right? Maximum voted option will be taken as our final answer, right? Similar kind of concept, guys. Similar kind of a concept is called the ensemble learning. Ensemble, a very very famous concept. Ensemble learning in the machine learning, guys. Instead of one decision maker, instead of the one decision maker like this way. So this is one decision tree. So instead of one decision maker, guys, for the prediction, I am trying to take the multiple decision trees, or I am trying to take the multiple algorithms together. Multiple algorithms together. Let's try to understand this way. Let's try to understand. I have drawn already the diagram. I was able to explain this to the other people at that time. I have drawn this diagram. Let's try to understand this way. What is going to happen? Okay. So that they get guys in ensemble technique. Okay. Let me go here and let me tell you. In ensemble technique, guys, when we talk about the ensemble approach. So in ensemble approach, guys, there are three methods actually. One method is called as bagging. One is called as stacking, bagging, stacking, and boosting. Guys. Bagging, stacking, and boosting. These are the three approaches in ensemble method. And one of the approach, which is similar to the bagging, guys, which is the similar to the bagging is called as random forest. Random forest, okay? So bagging approach. Let's try to understand what is this approach and what is going to happen and what is this random forest. Let's imagine this way, guys. So in bagging, what happens is in bagging, we try to take our data set, right? We try to take the data set, and whatever this data set is here, guys, on the data set, guys, we try to build a multiple model. We try to build a multiple model, like build a same data set, whichever data set we have, we try to split that data set into the train test, obviously. Some portion will be trained, some portion will be test, guys. And but at the same time, we try to not only we are building we're not only building one algorithm, we are trying to build a multiple algorithm parallelly, guys. Multiple algorithm are trained parallelly. Multiple algorithm are trained parallelly, like model 1, model 2, model 3. And then, guys, after this model are trained on the data set here, okay, and then we try to take the opinion of them. So let's imagine your model 1, number 1 has given one result, model 2 has given two result number 2, model 3 has given result 3. Now these are your prediction. Now what will become my final prediction, guys? What will become my final prediction is, if it is a regression, guys, then I try to take the average mean of all the values. That will become my final prediction, mean of all values. In the bagging, right? In the bagging, I'm trying to train the multiple models simultaneously, guys. Multiple. These models could be decision tree. This model could be decision tree, or this model could be anything, guys. This model could be logistic regression. This model could be SVM. This model could be chain nearest neighbor. So any classification algorithm is possible, guys. We try to train multiple algorithms simultaneously together on the same data set, and then we'll try to look at the prediction. So this is prediction, and within that prediction, guys, if it is a regression, we try to take the average. We try to take the average of all the result. That become my final prediction. If it is a classification, guys, then what will happen? If it's a classification, let's model 1 says P1, model 2 says P2, and model says P3. P3 are this prediction, okay? And the prediction out of this P1, P2, P3 prediction, let's imagine this way. So these are the prediction of the models, okay? So model 1 says 1, class number 1. Model 2 says class number 2, and again model number 3 says class number 1 here. So what is my most voted? My most voted will be 1, right? So my final prediction become 1. Guys. So this is called as bagging concept, and this is what goes on, guys. This is what goes on. So whatever the data set we have here, we try to train a multiple models like this one, and these multiple models will give you a multiple result, guys, this way. And out of that result, we try to do either regression or classification. We take an average, or we try to take the most voted, guys. Most voted option. Okay, this is what happens. So what we're trying to do is we try to train on. Now coming back to the random forest now. So in random forest, what is happening? Try to come down here. So now you guys are understood what is ensembling technique now. In random forest, guys, whatever the data set we have, right? This data set we have, guys. So in random forest, guys, we are trying to train on the same data set. We're trying to train the multiple decision trees. The decision tree 1, decision tree 2, decision tree 3, decision tree 4, and so on, guys. So on. There is no limit. You can go up to any kind of a limit. No limit is there, guys. You try to build the trees. Okay, you can build the multiple trees together. And then, guys, after building the multiple trees together, so whatever the prediction is there, so that out of that prediction P1 is given, P2 is given, P3 is given, and P4 is given, right? So P4, out of that, guys, the most voted, like I told you, the most voted most voted class, most voted class of the result will become a final prediction for the classification. And for the regression, I am going to take the average of everything. Average of all the results, P1 plus P2 plus P3 plus P4. All the average of this will become my final number, regression number, guys. This is what happened. Now try to understand what is the difference. What is the difference between this bagging? What is the difference? Because you will say, sir, bagging is also same and random forest is also same, right? Random forest is also doing the same thing. Now there is some basic difference, guys. Random forest algorithm, there is some basic difference. Try to understand what is happening. In bagging, guys, what is the basic difference in bagging? I can take the algorithm, base algorithms, whatever the base algorithm we are taking, I can take any algorithm as a base algorithm, any algorithm. That algorithm could be KNN, K nearest neighbor, could be SVM, could be logistic regression, or could be decision tree, or could be anything else. But in the random forest, guys, in random forest, base algorithm, okay, the base algorithm is always a decision tree. Base algorithm is, guys, always a decision tree. Okay, so that is the basic difference. Then second difference, what makes the random forest? What makes the random forest, okay, so different from all algorithm and random forest special? What makes the random forest, okay, sorry. So what makes the random forest special of all the algorithm and very robust? Let's try to understand the second feature. So this random forest algorithm, guys, the feature selection technique. The feature selection technique which is uses internally, guys. Feature selection technique which is uses internally, guys, it is a game changer. It is a game changer. Try to understand how it is a game changer. Try to understand. Let's imagine that I have a p number of features, p predictors. P means p predictors. Okay, p predictor. See, predictor is in this way. Okay, try to understand. P predictor means what? Predictor means let's take the same example. For this example, okay. So I'm trying to find out whether the person is diabetic person or a non-diabetic person. Non-diabetic person, that kind of a things. Non-diabetic person. Okay, this is the prediction I'm trying to do. For that purpose, guys, I'm trying to take the insulin level. Let's imagine insulin level. I'm trying to take the pedigree function. I'm going to take the skin thickness. I'm going to take the pregnancies. Going to take the gender. I'm going to take the BMI, and so on, guys. There is a list of all the features. So let's imagine I have a 10 features, such 10 features. These features are called my predictors. By using this predictor, I'm trying to find out my target value, right? My target value. This is my that target is diabetic or non-diabetic. This is my target, right? Diabetic or non-diabetic. So guys, try to understand random forest. Random forest, what it does, guys. So I told you that random forest will try to build a decision trees, right? Like this way. Decision tree, guys. So all the decision tree. Let's imagine this is the decision tree. Now this decision tree could be, guys, anything starting from 1 to 1000, or could be beyond also 10,000 possible. We don't know actually. It is up to you, guys. It's up to you how many decision tree you want to understand. Okay. In bagging also, guys, in bagging also, if I try to take my base algorithm in bagging ensemble method, if I try to take my decision tree as my base algorithm, it will happen same. It will try to create a different trees. Now, what is the difference? What is the difference between random forest and bagging, and what makes the random forest very special, guys? This way, this formula, m equal to root p. M equal to root p. Now, what is happening is every time, guys, every time out of my p features, out of my p feature, every time out of p features, guys, I try to take random m feature. Random m feature, random m feature to create or to build the decision tree, guys. To build the decision tree. This is what is done. This is what is done by the random forest. So if I am trying to do a bagging, guys, and if I'm trying to do a bagging, and let's imagine I have a 10 features. So in bagging, guys, all the 10 features will go in all the decision trees. All these 10 features will become a part of all the decision trees. So whatever decision tree I'm creating here, okay. So but if this is the situation of random forest, guys, out of this 10, some m feature will go. Not all the 10 feature will go, or some m feature, and that equation is given by this way. M equal to root p. Let's imagine if I have a let's imagine I have a 25 features. So root of 25 will be 5. So every time I will try to take a combination of 5 features, 5 feature combination randomly taken, okay, randomly taken 5 features, and then that 5 feature will become my decision trees feature, and I will try to build one tree. Next time, guys, next time I will second tree. Next time also I will take a four other random, five features, and then I will try to build a tree. Then I'll try to build a third tree, fourth tree, fifth tree, and so on, guys. So these M features are taken, not all the feature. Why we are taking this feature and what is happening, guys? So means whatever decision trees I am building here, okay, whatever decision trees I am building here, every tree is unique, guys. Every decision tree is unique, and every decision tree will try to find out the different patterns, and this will make my entire random forest algorithm a robust one, very robust and ready for the patterns, guys. Because every time I am not going to build the same tree, every time I am building a different decision trees and different combination, different variation, different pattern. So that makes a random forest very special, guys. That's make a random forest very special. And this way it is one of the ensemble technique, but it is different. It is different from the bagging, guys. It is bagging classifier. So you guys are already aware, my thing. Bagging classifier. Bagging means number of 10 or 10, 20 algorithm taken together, and then we try to predict them simultaneously. They are trained on the same data. So that kind of a differences is there. Okay. So try to remember this M equal to root P. So this formula, by using this formula, guys, they will try to create a unique trees every time. And this is a collection of tree. It is a collection of trees. So it is a random forest. It is a random forest. So guys, any doubts, any question? I am sure you guys have heard of the random forest, but you might have not heard of this concept internally, how it is trying to juggle the features. Okay, juggle the feature. That makes this random forest unique, guys. All right, guys. So everyone comfortable, everyone understood random forest, everyone understood decision tree. So before 5 minutes code walkthrough, I'll make a 5 minutes code walkthrough, and then we can start a artificial neural networks, guys. Okay, still we got a half an hour, so we can start the topic now. So guys, meanwhile, if you have any questions, any doubts, anything, please let me know. So I can share my code window with you guys, and we can start making the code walkthrough. So let me go here. Just a moment, guys. Meanwhile, you guys can ask if you have any questions, any doubts, guys. Please let me know. So I can take the questions. Okay. Okay. No question, guys. Nothing. So let me share my code window with you guys. All right. So you guys can see my code window, I think. So let's try to understand this way. So guys, I'm going to create one decision tree here, and I'll try to show you the visualization as well. So let's imagine this way. Okay. So, so guys, there is one. There are actually. Let's try to understand decision tree also. There are different algorithms. One is called as ID3. One is called as C5 now. Actually, the 4.5 has become 5 now. And one is called as CART, guys. CART. CRT CART. So this ID3 is iterative dictomizer. Iterative dictomizer. So this is what it is called as ID3. So guys, it was previously used for only for the classification purpose. Then we have something called as C5, C4.5 or C5. This C5 was used to for the classification purpose only, but it used to be used for a different category of variable, like categorical variable as well as the discrete and continuous variable. Okay, this is what it does. And then guys, the final algorithm, which is one of the best algorithm, is called as CART. This CART stands for classification. Okay, here it is already written, so no need to write. So it stands for classification regression tree, guys, CART algorithm. So we are going to implement CART here actually, CART algorithm. So it is one of the algorithm, guys. CART algorithm, one of the decision tree algorithm, the decision tree, the CART, classification and regression tree. Okay. So it is used for both purpose, classification, regression, same function. So you previous function were only used for the this categorical variable for the classification purpose, Okay. So this is what. Yeah, guys, my colleague will share the attendance sheet. Okay. Don't worry. So guys, we're going to implement this algorithm and then we'll try to understand. Okay. So first thing, what I'm going to do, guys, Amar has shared the attendance link and feedbacking. It is one of the same, guys. So you can refer in the chat box. Okay. So you can follow that. Okay. So guys, try to understand now what I'm going to do. I'm going to fit this CART algorithm here. CART algorithm for the decision tree. So I'm calling first pandas, then graph with guys. This library I'm calling to visualize my tree, guys. To visualize my tree. Okay. So then I'm calling my decision tree classifier and export graph with this function. Don't worry, I'll explain you what this export graph with will do. It will try to show us the graphical representation of whatever tree we are creating. Then I'm calling this trend test split standard scalar and we already discussed confusion matrix, ROC, AOC score, and accuracy score. Okay, this is what I'm going to import, guys, and export this I already told you. Okay, so what I am going to take, guys, I am going to take this different data set now. So it is a multi-class classification. There are actually 10 to 12 classes are there. So these classes are about the wine quality. So if I try to provide you this kind of a feature, so what is my quality of the wine? And the quality differs from 1 to 10 categories. There is a ranking given. So what number 1 wine, number 2 wine, number 3 wine, number 4 wine. Okay, this kind of a data set is there. And try to understand this one. Wine quality data set I am importing. Then I have a feature, something called as fixed acidity, volatile acidity, citric acid, residual sugar. How much is the residual sugar inside that? What is the free sulfur dioxide? What is the total sulfur dioxide? What is my density? What is my pH scale, sulfate scale? What is my alcohol level? And once I provide this kind of information, guys, I can predict what kind of a wine quality is this one. Wine quality. What kind of a quality of wine is this one? So this kind wine quality ranges between 1 to 10 or above. These many categories are there, wine categories. Okay. So I have to predict this wine category. So which category this wine belongs to if I have this kind of a properties. This kind of a property. This is my data set, guys, all about. Okay. So let's run this data set. Let's import this data set. And once I import this data set, guys, this all features will be my X. Yeah, guys, the Samiran's Begum ma'am. The attendance link is already shared by my colleague. Okay. So it is the same link. You can refer here. So let me share it again in the chat box for everyone, guys. I'll share it again. This is the same link for the attendance and feedback. Okay. I've shared it with everyone in the chat box. You can refer. So guys, let's understand this one, wine quality. So guys, I am going to import this. You can see that fixed acidity, volatile, these kind of scores are there. And the final prediction will be between 0 to 10, guys, between 0 to 10. So what I'm trying to do first, I'm trying to describe my data, check like how many missing values. I have a total 1600 values. So how many missing values are there, outliers are there, what is my max value, what is my main value, what kind of a scaling I have. So that kind of a things I'm doing. Then I'm trying to split my data X and Y, guys. X will be all other features and Y will be my target column. I'm trying to split in 70-30, guys. See here, test size I'm giving 30%, 70% I'm giving for the training purpose, guys. Then I am calling my decision tree classifier here. Decision tree classifier CLF. I'm calling that as the CLF, decision tree classifier, and then passing my training data X train, Y train, guys. So this is training. Once I train, guys, once I train, what is going to happen is now I will try to take the feature name. And then we can try to keep this feature name and we try to provide one kind of a graph, guys. So what is this decision tree I have fitted here by using this, right? Decision tree classifier I called upon. And once I called, I said dot fit and pass my training data. Then guys, I try to share my feature name and class name in some variable, call that feature name class name. Why? I tell you why, because I have to show these things out here in the graph, right? Which graph is taken, which root node is taken first. So for that purpose, remember here we imported one library called as export graph is and this graph is library. This will help us to visualize the tree, what is going on in the background. Okay. So what I'm trying to do here. So I'm calling this export graph with, then I'm passing my classifier, decision tree classifier, and then the feature equal to the feature name, the name of the column name or feature name, and my target value classes. Our classes are called as my unique classes. So that I'm passing here. Feature name equal to feature name, column name, rounded equal to yes, true, field equal to true, and then just this is the hyperparameter, please make it true, and that's it, guys. You provide your feature name, you provide your decision tree, and you provide it to the function called as export graph with, and the graph equal to then pydo plus this is also library from pydo library graph from dot data. Dot data means our data, this data only, this whatever classifier, whatever the feature name we are passing. So please show that dot, and then I'm saying graph dot write dot png means it will try to save the same graph picture also here in the png format. Okay, and then I'm trying to showcase this by create a png, create png, graph dot create png. All right. So there is other function also, show graph, graph is also. So that is a simple version, that is code is also available, guys. I'll share to show you. So guys, once I create this, you can directly visualize here. See here. So it has taken now alcohol percentage. See here, alcohol percentage. And now you try to see here, it has taken alcohol percentage as our root node. And if let me tell you, whenever we try to use this cart algorithm, guys, whenever you try to use the cart, above link is not opening. Okay, okay. Amar, some people are complaining that the above link is not opening, this attendance link. Can you please check and drop them the message in the comment chat box? Okay, guys, Amar will help you. Don't worry with this one. So he will try to check and he will try to get back to you guys in the chat box. Okay. So guys, this cart algorithm, when we are using the splitter, like you remember the splitter function, like whether to use the entropy function or whether to use the Gini impurity. So guys, this cart algorithm by default it uses the Gini index, okay, Gini impurity for splitting the root nodes, okay, decide which one become the root node, guys. So that is why you can see here it is written Gini, and then Gini score is given for this alcohol algorithm. This alcohol feature is taken first, guys, and then it become root node, and then we try to create on the total sulfur dioxide, volatility, acid, and other features. And this is what, guys, you can check the number. You can check even values also. You can see here values are also given here. So what values are taken, what the things are given. Okay. So guys, Amar has shared the new link again, once again. So please, yes, guys, Bharti ma'am, yes, I will share this entire thing also with you guys. Don't worry. So in this session only, once we finish the code walkthrough, I will share. I'll try to share here only. Don't worry. So guys, you can check here. Entire visualization is created. Decision tree. What is the root node? What is the Gini index it is getting? And what are the samples? You can see actual values also. What values they have taken. More than that, less than that, an entire graphical representation will be shown, guys. Okay. So this is what we have fitted the tree. And once we fit the tree, guys, then I am trying to check my score. CLF.score. You can see 100% one. So that means something is wrong. My decision tree is going very high. So I can do a prediction also. And I can try to check the scores, guys. You can check here. So it is giving a test score of 57. And here, okay, guys. I am going to share the attendance list once again for everyone. Okay. So I've shared it for everyone, guys. You can check it for me. So guys, this kind of a situations here, the score for the training is high, 100%, and score for testing purpose you can see 60%. So this time, guys, you have to bring your regression factor. Okay. So this time you have to bring your regression factor and you have to regularize the parameter, guys. Regularize the parameter. Now see here, what I'm trying to do now see here, guys, this is a real-time situation. See here. So try to focus, guys, for 2 minutes and try to look at this situation. So CLF score, you can see CLF score here. CLF score means training score. Train data I passed. 1 means 100% accuracy. And when I'm trying to do a testing, guys, here CLF.predict, I'm doing testing. Testing score is 60%. What is the huge difference I have? Here it is showing 100%, it is showing 60%. 40% of the gap, guys. 40% gap. Worst situation. Worst situation. This is not model is very not a proper model, guys. Very you can say fragile model. It's a very fragile model. Okay. So this model, this is what I am not supposed to do. This is what the real-time situation you will face, guys. Okay. So if you face this situation, what to do then? What to do? The two methods are there. Two methods, 2 to 3 methods you can do, guys. If you try to find out the situation. One, you use a standard scaler. You try to normalize your data. Standard scaler, scaling, normalize your data, guys. Normalization. Do standardization normalization. Then bring the pruning. Pruning method or bring the regularization, guys. Or you have to increase your data set. Increase the data set. Whatever data set is there, try to increase the data set. Or you have to change the algorithm. You have to change the algorithm. This algorithm is not fitting good to the data. You have to change the algorithm, guys. So this, or we can do a hyperparameter tuning. Last thing is hyperparameter tuning. Hyperparameter tuning means how much is the depth you are taking, how much is the sample leaf you are taking, which criteria using for splitting. All these things are called as hyperparameter. You have to change these things, guys. So what I'm going to do, once I'm getting this kind of worst situation, see here what I'm trying to do here. I'm trying to create a standard scalar and transforming my data now. By using standard scalar, then I'm splitting my data 70-30, guys. Then I'm doing PCA also, dimensionality reduction technique. See, PCA dot fit, I'm passing my X data, features are passed, then I'm trying to plot my data. Now I can check out of all my 10 feature, guys, only this much features are important for me. 6 feature, okay, this point where I'm getting 90% of variance. So this is the point where I took only 6 features. So I'm transforming my PCA also. I'm doing PCA also. See here, 2 methods I've done. I have used PCA. I use it a standard scalar. And then, guys, I'm passing this PCA dot fit transform. Whatever the scaling data is there, then I'm passing. And then I'm checking. Then out of that, I'm creating only 8 components. And then I'm fitting my data, fit transform. And once I transform, guys, my entire columns are changed now. They become the principal component. And with this transform data, guys, with this transform data now I'm trying to fit my models here. I'm trying to fit my decision tree, 10 test and score, guys. Now you see here the score now, the training test score, guys, come down now. Little good accuracy, right? Little good accuracy now. I can check the parameters also, see here. So whether I can use a Gini or entropy, what is the max depth I want, how many ranges so I want. I can pass this kind of a character to grid search algorithm, and this grid search algorithm will give you back which are my best parameters. Grid search dot best parameter. And once you fit that, guys, once you fit that, you can check your accuracy is increasing here. So this is how, see here. Both the training and test accuracy now are very close to each other. Great. That means our score is improved, guys, after grid search. Okay. So this is how, guys, this is how we can entirely fit your decision tree, guys. Okay. And let's same way, let's try to fit our random forest algorithm. Let me share that window with you, guys. Come on, random forest. Where are you? Just a moment, guys. Let me share my random forest with you, and then we are done. Yeah, yes, it's here. All right, guys. So let's try to understand. Here I am taking this time, guys. I am taking the different data set. I am taking now for random forest, guys. I am taking this kind of a diabetic data set. Okay. So pedigree function, age, then mass, body mass index, then test skin thickness, pressure, blood pressure, alcohol level, glucose level, and the pregnancy. This kind of feature. And my target will be whether diabetic or non-diabetic. Okay. So this kind of a data set I am taking, diabetic data set. Guys, try to understand now how I am fitting this regression tree now here. On this tree, guys, I am taking the data, I am splitting the data into X and Y. So Y will be this class and all other things will be my X, guys. Okay. All other feature will be X. So I'm taking one more thing here, which is called as the k-fold classification, guys, k-fold cross validation. So this is nothing but it is trying to split the sample data into the various samples, and then it is trying to feed the data, guys. It is trying to feed the data. So see here, I'm taking base algorithm decision tree and calling bagging classifier as well. Bagging classifier, you have to pass the decision tree. Number of estimators means how many trees you are fitting. I'm taking 100 trees, guys, 100 trees. And then I'm checking the score, guys. You can check the score now. Look at the score, 75% now. Okay. Now, same for same tree, same thing, everything. See, guys, now I'm calling random forest now. I'm taking random forest classifier, cross validation score only, sampling technique, and splitting my X and Y, guys. Max feature, I'm taking 3. Number of trees also 100, I'm taking 100. And split also, I'm taking 10 split. Now, don't worry, like, don't get confused. This k-fold means this way. This is k-fold. K-fold means what? So if my entire data set is there, so I'm saying 10 split means my data is split in 10, guys. I'm trying to draw 10 random samples. Sample 1, sample 2, sample 3, sample 4, and sample 10. So 10 sample will be created out of original data set. Original data set is there. Out of that, 10 sample will be created. Those 10 sample will be fed to my random forest classifier, guys. So instead of taking entire data as one time, at one time, if I am taking my entire data set, rather than that, I am trying to take a random samples, different random samples, and that samples I am passing to my algorithm. Okay. So this is what the only k-fold is doing, guys. Don't worry, nothing else it is doing. It is just trying to split my data. If it is saying 10 split means it will try to create a 10 random samples. 10 random samples out of my entire data set, and those will be fed to my model. Okay, that's the only difference out here. Then I'm calling my random forest classifier, guys. I am taking 100 decision trees, same thing. Max feature means as per the feature importance. I told you that whenever we try to take the random forest, we will try to find out internally what is the feature importance, and it will try to take the m out of the pre-predicted, right, root p. So that kind of a things we are passing here. What max feature you have to take, and once we pass this, guys, now you check the score. 76%, right? Simply call your function. Call your function. Once you call your function, guys, and try to pass how many decision trees you want, how many max feature you want, and what is the estimator. Estimator is decision tree. So you just feed your model here, X and Y, and check the score, guys. That's it. Your entire job will be done. Attendance link is not opening. So Amar, everyone is complaining that attendance link is not opening. Amar, can you please check? Amar, are you there?
It's working properly. There is no any issue.
So some people are putting, can you please speak with them, chat with them? So what is their issue? So I continue my lecture then. Okay.
No, it's working.
Okay, guys, please check. Amar is saying working. Dharam sir, please check another whosoever facing issue. So guys, this is how I fit my entire random forest algorithm, and this is how the random forest will work, guys. And you can see the accuracy is very nice, 76%. Okay. So guys, any questions, any doubts here? How we are trying to fit this random forest? How we are trying to fit the decision tree? Anything else? So we still got 12 minutes, guys. So we can start a fresh topic, artificial intelligence. At least we'll try to start the introduction. Then I'll continue tomorrow the operation of the artificial neural network. And then we'll try to also understand tomorrow dedicate the topic to NLP. So before I start, guys, next topic, anything else here? Yeah, code. Okay, guys, code I have to share, right? I have to share the code. Yes, guys, I will share this code with Amar, and Amar will share with you guys, this code. Okay? Amar will share with you this code. Amar, I will share today AOD this code, whatever codes I have spoken today, and you can upload it to LMS. Guys.
Yeah, sure.
Okay. So, guys, anything else, guys? Thank you, Naresh Babu, sir. Thanks for your confirmation. So, guys, anything else? Any other doubts? Any questions before we start? So, meanwhile, let me share my presentation with you guys. Okay. Gini index going smooth. Okay. Uh, Yumnam, ma'am, you want to understand Gini index or what is your question, guys? Nice session. Samir and Banu, Begum ma'am saying. Someone is saying Gini index, Yumnam, Momojit. So, do you want to understand Gini index or what you want to understand? If you are written only Gini index, can you please elaborate your question so I can go ahead and explain you if you want? And before we start this AI topic, please repeat. Okay. Okay, guys, I will repeat. Okay. So let's imagine this way, guys. I will try to finish this recap of the index and we'll try to understand what this artificial neural network is all about, guys. This is the topic we're going to understand. Gini index is calculating negative probability. Yes, guys. In terms, you can say it is calculating, but try to understand what Gini index is doing, guys. Let's imagine this way. So let me tell you again. The formula for Gini index, guys. Formula for the Gini index is this way. So 1 minus summation of I equal to 1 to C, you can say Pi square, guys. Pi square. 1 to C Pi square. So this is my formula for Gini index, guys. Okay. So what this is called as Gini index formula. I shown you guys entire calculation, like how we try to come to this formula, right? I have derived and shown you like how it is happening. Okay. So this is my formula. Try to understand this way. And let me tell you the definition of the Gini index. Like what do we mean by Gini index? Try to understand this way, guys. Okay. So Gini index means what? Simple definition. Try to understand the definition of the Gini index. What is Gini index means? Gini index means, guys, let's imagine if you have a data set. This way, you have a data set. Out of this data set, guys, if you try to take one random data point, you are taking one data point. Okay, data point you are trying to draw actually randomly. And once I take this, let's imagine this from here, I am taking one random data point. This is my random data point. Now, guys, what I have to do is I have tried to classify this data point. I have to classify this data point. What I have to do is I have to classify this data point, that which class this belong to, which class this belong to. This is what I'm trying to do now. And when I'm trying to classify, guys, when I'm trying to classify, I am trying to measure the probability now. I am going to measure the probability. So what probability I have to measure? What probability we want to measure? So what are the chances? What is the percentage that? What is the percentage that this whatever classification I am doing, whatever this random data point I have taken, and whatever classification I'm doing, that I am going to do it. I am going to create this classification. So whatever this classification I'm doing, I'm going to misclassify it. I'm going to misclassify it. Misclassified means if I am trying to do a classification of this data point, so what are my chances? If I am trying to do a classification, so what are my chances? Okay, what are my chances, or what are my percentage that I am going to assign? I am going to assign it to a incorrect class. Assign it to a incorrect class. Incorrect class. So that kind of a things is measured, guys, by Gini impurity. Gini impurity. So that is why you can say that it is calculating the negative probability also. Okay, not actual negative from the mathematical point of view, not calculating actual probability, negative probability, but it is a calculating the chances or the percentage probability of in classification, incorrect classification. Okay, incorrect classification, guys. This is what the Gini score is all about. So this is calculated by how? It is calculated by multiplying. It is calculated by multiplying the correct probability. The correct probability, percentage of the correct probability, correct class classification into summation of all incorrect classification. Summation of incorrect class classification. So incorrect classification. Okay, incorrect classification. And this is what it does. Summation of pi into multiplication of summation of pi. Okay, summation over the pi. So this pi will be called as like 1 minus pi, and then we try to scale pi, pi minus pi square, and this is how it pi will be called as 1 minus summation of pi, guys. This is what the entire happening. I think cart method. Okay, so the cart method is, guys, this cart method. This cart method is nothing but it is the same decision tree only, but in cart method, the splitter means to find out the root node. To find out the root node, guys, it is trying to use the Gini impurity. It is trying to use the Gini impurity. Now, obviously, why Gini? So you try to understand the entropy formula. Entropy formula is, guys, by this way: P log 2 P minus Q log 2 P, Q, right? But the Gini impurity is very simple, like this way: summation of P square. So, guys, when we try to think of the computation point of view, calculation point of view, guys. So everywhere here in the entropy, I have to calculate the logs, that to base 2 logs, for correct class, other class. Okay, then I have to do subtraction, multiplication, addition. But in the Gini, guys, I'm just taking 1 minus incorrect probabilities. So this is the simple calculation. That's why my CART algorithm, classification regression algorithm, it using the splitter to find out the root node is Gini, guys. That is the thing. And classification algorithm is nothing but same thing. It is trying to use the same thing: Gini, impurity, decision tree, everything will be same. Only by default it is uses Gini. Or you can give a entropy also if you want. You can give entropy also, but the by default it uses Gini. If you want, you can give a entropy also. You can go ahead and set up a model, guys. That's okay. Okay. So I think I try to answer your question, guys. Any other things, guys? Any other thing? Anything else? Anything else you I want to understand? So at least we'll try to start the introduction for 5 minutes, guys, today. And we'll try to understand what is this artificial neural network, and then we can continue these operations tomorrow, guys. All right, guys. So anything else? Yeah, okay, guys. Thanks for confirmation. So let's understand this one, guys. So what do you mean by like I told you guys now? So this entire part is AI, and the AI, guys, we have something called as machine learning, and in the machine learning we have something called as deep learning, right? So this we understood the difference. Machine learning use y equal to mx plus c, the statistical algorithm. Data is structured one, and deep learning technology, guys. Deep learning, they use artificial neural networks, and the data is unstructured one. Okay. So this is what understanding we already have. Now try to understand, guys. Now try to understand one thing that, so when I talk, when I'm trying to talk about, the this kind of a things, that is deep learning. So guys, deep learning uses the artificial neural network, right? Artificial neural network. So guys, try to understand what is this artificial neural network and what is this all about? What is this all about? So for that purpose, let's go back for 5 minutes. For 5 minutes, let's go to the biology class, guys. Let's go to the biology class and I try to understand the functioning, working of the human brain. So human brain functioning, and we'll try to compare this with the artificial neural network. Okay, guys. So when I talk about artificial neural network, ANN, guys, this ANN is nothing but, guys, ANN is nothing but a copy of biological neural system, biological neural system, guys. This is the copy, exact copy. And this copy neural networks, whatever neural networks we have in our brain, okay, let's imagine this way. This is whatever these neural networks we are trying to showcase, guys. This exact copy is done, guys. Exact copy is done here, and that is artificial copy, right? This is artificial copy. This is not natural, actually. This is not natural. This is whatever this human brain has. It has a cells, it has tissues, right? It has a biological part. But this artificial neural network, this is everything is artificial, guys. So they're trying to copy the functionality, guys. What do you mean by artificial neural network? Simple in one liner definition, if I'm trying to tell you what is artificial neural network, guys. Artificial neural network is a copy of the, it is copy or mimicking. We try to mimic the functionality. Copy the functionality of the human brain, and that to the copy of the biological neuron, guys. Biological neuron system. Biological neuron system, guys. Neuron system. So that is called as artificial neural network, guys. Artificial neural network. Okay. So this artificial neural network, I am sure you guys have seen this kind of a circle diagram. So this kind of circle diagram, guys, always. So whenever we speak about, and they are connected to each other. They are connected to each other. And this kind of a circle diagram is there, and this is what is called as artificial neural network, guys. Artificial neural network. This is what you guys might have seen. So this artificial neural network diagram, and this is a copy of the human brain, guys. Copy of the human brain. So if you want to understand artificial neural network, guys, okay, you have to understand that how the entire artificial neural network works upon, and you have to understand the functioning of the human brain, guys. So what we're going to do is we're going to compare. I know it's a time, guys. So I will not take more than 3-4 minutes. So in 3-4 minutes, we'll try to finish these slides today, and then we'll try to understand the entire functioning. Okay, tomorrow we'll try to start and elaborate this topic, guys. Let's try to focus here for 5 minutes, and we are done. So guys, if you want to understand the artificial neural network, you have to compare the human brain functionality with the artificial neural network, and you have to understand what is going on. So let's imagine, guys, this picture. Picture number 1 is showcase us. So this is the human brain. This is entire is the human brain, guys. In the human brain, guys, we have something called as the neural networks. Neural networks. These neural networks, which are shown with the circles, various color circles, and then in the end they are connected to each other. And this is how the human brain works, guys. This is how the human brain works. So what I'm going to do is, guys, and this is the left hand side, guys. This left hand side is the human brain, and right hand side you can see this diagram. Okay. So this diagram, we have something called as this one. So let me draw this with the different color and try to showcase you. So first let me rub the things. Okay, guys. So this is called as artificial neural network. So this artificial neural network, guys, it is divided into the three things. There are three parts. The part number 1 here. The first layer, you can call it layer number 1. So layer number 1 is, guys, input layer, actually. Input layer. This is layer number 2. This is the layer number 2. There could be multiple such layers possible. Layer number 2. This layer number 2, guys, L2 layer. This is called as hidden layer, guys. Hidden layer. Hidden layer, okay, hidden layer. And the last layer where we get our prediction, y hat, guys, that is called as output layer. Output layer, okay. This is what is called as output layer. So this has a 3-tier architecture. 3-tier architecture is there, guys. Okay, 3-tier architecture. So first one is input layer, then second is a hidden layer, guys, hidden layer, and then we have a output layer, just like the human brain. Okay, let's try to understand, just like the human brain, guys, just like the human brain. Okay, so we have this kind of a functionality. Now try to understand this way. Okay, so let's imagine this way. What is going on, guys? This human brain. Now out of this human brain, let's take the example of one human cell. This circle I'm taking, guys, and this circle I'm trying to expand here. I am going to expand this circle here, and we'll try to zoom in the circle. I am trying to zoom in the circle, guys. And when I try to zoom, guys, this kind of a diagram will be shown. This kind of a diagram will shown. And out of that diagram, guys, this is the first part. This first part is the same replica zoom in version, zoomed in version of this one single neuron, guys, one single neuron. And we'll try to understand, the functionality of the human brain, guys, how the human brain works. Let's try to understand. So, guys, this part is called as human cell, okay? Cell or nucleus, you can say nucleus, cell body, okay? This is one cell. Inside that cell, already everyone knows, guys. Inside the cell, guys, in the cell, we have a nucleus, and around the nucleus, guys, there are electrons, protons. So if you guys have heard, there are various atoms which are revolving around, and this some kind of information happens and some processing happens, right? Try to understand, guys, now what is going on. Okay, so some first part I told you about is cell, human cell. In this cell, guys, there is something called a nucleus, this nucleus. And around the nucleus, guys, there are electron, proton. Okay, electron, protons are there. This kind of a atom, neuron, proton, electron, this kind of a neurons are, this kind of a small particles are there. The minute little part of human brain is called as cell body. And within that cell, there are tiny particles. This kind of a dots. These dots are called as electron, proton, or some kind of atoms, right? Atom. We have learned this in chemical, in the chemical classes, in chemistry classes, we have learned these things, right? So try to focus, guys. Try to focus and try to understand what is happening here. Actually, this is cell body now. This is the one cell, and there is a multiple such cells are connected to each other. Multiple such cells, and this is the entire network. There is an entire network of such cells, right? Entire network of such cells. That network is called a neural network. Neural network, right? In this human brain is present in the human brain. Not only in human brain, guys, entire body of the human, this kind of a neural networks is there. Okay, that is a very mispopular conception, very misconception among the people, that in the human brain only there is a neural network. In the entire brain of the human brain, and also in the entire body, guys, there is a neural network. Let's try to understand this in 2 minutes, and we'll try to conclude this session, guys. Okay, so this is a cell, guys. Inside this cell, the processing will happen. And guys, these cells are, now you can see this kind of a lines are there. These vertical lines or horizontal lines are there. These lines are called as dendroids. Okay, these are dendroids now. And these dendroids are these are our information carriers. So these are our inputs, guys. The dendroids are our inputs. Okay, so dendroids are input. These dendroids are a sensory organs. So this dendroid will pass the information. They will pass the info, guys, to the cell body. And within the cell body, guys, the information processing will happen. And once the information processing happens, guys, then, guys, once the information is received and that is processed in the nucleus, guys, what is going to happen is based on the activation, based on some activation, guys, based on some information and importance of that information, whatever information received inside that neuron, guys, if that information is important, if that is information, whatever we have after processing that, if you think that is important, guys, this cell will glow. Guys. There will be some kind of a electricity. Will be generated. There will be some kind of a spark. Will be generated. That means that neuron is getting activated. Now, neuron is getting activated, guys. That particular neuron, this circle, cell body, it will get activated. And then once it is activated, guys, then only the information will be passed upon. Then will be the information passed upon, guys. Okay, the information will be passed upon, and whatever this information is passed upon, guys, that will be carried out. Towards the other things, other body parts, by using something called as axons. These axons. Okay, now you can say this part is called as axons, guys. This axon has a terminal, and through this it reaches to the different body parts. Okay, so let's try to take one example, and we'll try to understand the same thing. We'll try to compare this thing with our artificial neural network, and how we'll try to compare how this entire functionality is copied there. Let's take one simple example. And try to finish this. So let's imagine, guys, I am sure that you guys are able to see my hand. So let's imagine if I try to take this hand and try to put it to the hot object. Let's imagine there is a hot object out here. And if I try to put this my finger in the hot object, what will happen, guys? These neurons which are present out here in my finger, guys, they will get activated. These dendroids, okay, whatever the dendroids are there, these dendroids out here will get activated. That will pass the information and will reach to my brain, guys. It will try to reach to my brain. And within the brain, guys, there is cell body. this cell body will try to process that information, guys. That will process. And if I think, once whatever information is there, I'm touching a hot object, according to that information, that is very important, right? So I understand this is important. I'm touching a hot object out here. So immediately, guys, the brain will try to process that information, and the signals will be passed. The signals will be passed through the axon, and it will reach to my body part. In this case, it will reach to my finger hand. Okay, and then immediately I will try to take back my hand, guys. Immediately I will try to take back my hand. Okay, so this action will have performed. This action will perform. Now you understood entire thing, what is going on, right? So dendroid carries the information. Dendroid carries the information. It reaches to the head. Within the head, we have a biological neurons. This neuron process the information, and if information is important, they will get activated, they will glow, and once they glow, that then information will be passed on to the human body parts through the axon. Okay, this is what goes on, and this is how the entire body works, entire functionality works, and this is how the humans, they perform the action, guys. Human perform that, take the actions, take the decisions, and so on. This is what happening in the human brain, guys. Okay, so this is the entire human brain, how this functionality works. Now when they created artificial neural network, guys, they try to make an exact copy. They try to make an exact copy of the same functionality, but they have put it something called as in a statistical equation. They are trying to put it the same thing in the statistical equation. And tomorrow we'll try to understand how they try to copy it, how they try to copy, and how that has been shown in the bottom part here. So this is what the functionality artificial neural networks are doing, right? And how they are fitted here mathematically or statistically, how they are trying to achieve the same objective, how they are trying to activate the signals, how they are trying to pass the information. Everything we'll try to understand, guys. All right. So we'll try to continue this discussion, and we'll try to compare this, and I will show you the entire mathematics operation, what's going on in artificial neural network, and we'll try to make a code walkthrough. I will try to solve one live case problem using the ANN, guys. Using the ANN, and then we'll try to discuss the NLP. This is what the two topics we'll discuss, guys. All right. So guys, thank you very much for today's time. Thanks for your patience. So I know it is a 7 to 8 minutes late, and I hope, guys, you understood the entire working and the logic, and I hope you enjoyed today's session as well. All right. So guys, yes, attendance link I will share, guys, again in the comment chat box for everyone. So my colleague Amar has already shared. I will also share again. Okay, guys. So guys, please let me know. Hope you enjoyed today's session. You understood in their working of the algorithm in detail. Okay, and we'll try to continue, make it very exciting, guys, tomorrow as well. All right. So guys, thank you very much. That's it from my side today, and we'll meet tomorrow again, guys. So you can go ahead, ask if you have any questions, any doubts, anything, guys. So I'll try to answer them. Otherwise, we'll conclude this session in 2 minutes. Then. Thank you, Karthikeyan sir. Thank you. Thanks for your kind words. Thank you, Venugopal sir. Thank you. Anything else, guys? Otherwise, I will hand it over to Amar. Amar, all entire stage is yours. Go ahead, please.
Yeah, sure. Thank you so much. So, dear professors, I already shared the attendance link in the chat box. So, please mark your attendance and don't forget to share your valuable feedback as well. And whatever the material is there, so by today end of the day, we'll upload over LMS so you can access from there. I have attended the session on 14 and 15, but have not filled the attendance. You have to mark your attendance because 60% attendance is mandatory to get the certificate. Yes, we are done with the 4 days, and tomorrow will be the last day of this training program. What can we do now? There is no any option because on first day only in the LMS KT, I only inform that the attendance is mandatory. You have to mark your attendance. And we are sharing that multiple times, more than 5-10 times, and our trainer is also informing to mark your attendance. So there is no any communication gap regarding to the attendance from our side, I think. How to access the LMS? So you can drop an email to edl@textlab.com as well. Already done with the KT. Our team member will connect with you. So if you are facing any difficulty, they will help. I'm sharing the email ID with you. Team, any another question or query? I think there is no any query questions, so we're done with the day and we'll meet you on tomorrow at same time. Thank you so much, all of you. Thank you, Vikas.